Hi everybody, it's video note 7BC. We're going to talk about molecular compounds and the properties of all the kinds of bonding that we're looking at in this unit. So here's one of the objectives. I can distinguish between different categories of atoms and compounds. So we'll be talking about properties, we'll talk about evidence, and of course there's ChemCat with a bad joke. Here's another objective. You can write the names and formulas for ionic and molecular compounds and categorize compounds when you see their name or formula. So molecular compounds, and I want to put here that I'm going to also put the word covalent. So when I talk about molecular, I'm talking about covalent compounds, which is the type of bond that's holding them together. Okay, so molecular compounds start with nonmetals. So we know where the nonmetals are on the periodic table. Any compound that starts with these things, it's going to be molecular, right? So because it's molecular, it's not made of ions, so we can't put metals and nonmetals together. It's just going to be nonmetals bonding. So we're going to use prefixes to tell how many atoms are in the compound. So 1 is the prefix for mono, 2 is di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So get to know these prefixes. All right, so here are the rules for naming molecular compounds. You never use the prefix mono on the first element, but otherwise you use prefixes all the time. Always, all the time, except for mono on the first. The second element in the compound, the word's going to end in IDE, and we never put double O's in. So it would be monoxide, but not it'd be monoxide. I just said monoxide, but not monoxide. Ooh, no. Ooh, no. Okay. So here's CO2. Now, how do I know what kind of compound it is? Well, this is a nonmetal, and this is a nonmetal. So right away, I know this is going to be a molecular covalent compound. So I will say the name of the first one, carbon, and then I need a prefix, but wait, there's only one, so no mono on the first. Say the name of the second element, oxygen, change it to "ide", oxide, and tell how many. Dioxide. So that's one you're familiar with, and now you know why. Nonmetal, nitrogen, and there's 2 of them, and I do need a prefix if there's 2, so dinitrogen, and then 5, pentoxide, dinitrogen pentoxide. Okay, nonmetal, so now there's 3 O's, so trioxygen, and 7 fluorines, so ide, so 7 is heptafluoride, okay? So that's how you name those, and they're nonmetals and nonmetals bonding. Okay, so you can tell if things are atoms, ionic compounds, or molecular covalent compounds with a microscope. If you have a good enough microscope to see the structure, you can tell. So these are atoms, and you can tell they're all yellow, so they're all the same atom, and they're bonded together in little groups of rings. These are also atoms, and they're held together by just the attractions between them, and they're single blue things. These are also atoms, and you can see that they're bonded together, and then there's like layers, right? These are atoms as well, and you can see that the bond is a little stronger because there's a connection between them, okay? So how do you know if it's atoms? And atoms represent elements, the same color or one type of atom, okay? That's how you know. They have variable strength. Like these could be gases because there's not very many attractions. These might be solids, but these are going to be little particles, and then if there's attractions between them that are strong, they could be solid. So variable strength means they could be solid, liquid, or gas. Liquid or gas. This represents metal atoms because you can see the strength between the bonds. Even though they're all the same atoms, there's strength holding them together to make it solid. Okay. Let's look at some other ones. You can tell if something is an atom, an ionic compound, or a molecular compound if you look at under a microscope. Okay, so ionic compounds are going to be a lattice, which is just a pattern, repeated, and bonds all around, and bonds everywhere, bonds everywhere, okay? And there's many bonds. And it's always different atoms, and they're really strong. So green, red, black. all the way through. You see the bonds, you see the repeating pattern, it's the lattice structure. Purple and green, bonds, patterns, structure, okay? And so if it's ionic, it's of a pattern of ions. So there's positive, negatives, positive, negatives, positive, negatives, positive, negatives, positive, negatives, positive, negatives all the way through. And you can see the strength of the bonds and the repeating patterns all the way through. Here we go again. Light pink, dark pink, or purple, bond, 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 lattice, structure, strong. So these are going to be solids. Ionics are solids. Ionic compounds are going to be solids because of the strong bonds and the pattern. Okay. You can tell if something is ionic, an atom, or molecular. Molecules are going to be two different nonmetals, all right? And they're going to be separated units usually, and it's going to be weak between units. So here we go. Here's a unit. So we got the red, the gray, the red. So this is a molecule. All right, I took it out of here. And the bonds here are between two nonmetals, right? But then between this molecule and the next one, there are not strong attractions. So between the molecules, which I'm calling units, no attractions, weak attractions. So this could be a gas or a liquid. All right, so here's a molecule. Whoa, look at that. But then the attraction between that and that is the weak in between, but strong holding it together. All right, so here's, let me find one. Here's a molecule. And it's bonded together, so you see the bonds, but then it's weak between this molecule and that molecule, so they could be solids, liquids, or gases. Solids, liquids, or gases for molecular. So all the ones on this page are molecular, and remember, sometimes we call molecular covalent. Okay, the shapes of the compounds or the bondings of the compounds determine their property. Ionic compounds, here's the properties. High boiling points, high melting points. Because it doesn't take a lot of energy to make them turn into a liquid, all right? It's going to take a lot of energy to make them turn into a gas. And they don't conduct electricity when they're solid because those ions are locked in place, right? If you melt them, though, they can conduct, and if you dissolve in water, they can conduct, okay? Because they are made of charged particles. But when they're solid, they are locked. The electrons get transferred from one atom to another, and then they lock in place. Positive, negative, okay? So their shapes or their bonding structure determines their properties. All right, so here's covalent, and then remember that's our molecular, okay? So their boiling points are going to be low because in order to boil, you just have to overcome this force, and so that can boil, so it could have a low boiling point and low melting point. They don't conduct electricity because there's no ions ever. And they're holding together. The covalent bond makes the molecule. All right, so covalent bond, covalent or bond, molecular bond, all right, makes the molecule. But then this molecule and this molecule, these forces in between are weaker, okay, than those ionic. So they could have low melting and boiling points. Okay, atoms, it varies, right? They can have variable melting and boiling points. So atoms that are individual and no bonds in between are going to be gases. They could have a low boiling point and low melting point. But metals have high boiling points and melting points because of the strength of the bonds in between. And then metals conduct electricity because their electrons can still move. Electrons can move. So the electrons and these are always in motion, but they can't go from one to another. So metals conduct electricity because their electrons move. So because they're so close together and their bonds are strong, the electrons can move across. So this is strong. So these are strong, and these are in between are weak. All right, so compare bonding, and this is a good way to look at it. Remember, covalent's molecular. Metallic bonding, what's in a metallic bond? Metals. The electrons can move throughout, so they can conduct electricity. They have generally high melting points. They generally don't dissolve in water, and their bond strength is variable, but because they have those connections in between, right, then it's going to usually be strong. Covalent bonding is two nonmetals. Electrons go in between atoms and stay So they don't make ions. So there's no ions. They never conduct electricity. These are the only kinds of compounds that could have low melting points and boiling points. So some of them are soluble in water. We'll get into that a little more. They have high bond strength to make a molecule, but low attractions between molecules. So that's the, oh, look, this is a strong bond to make a molecule, but, so that's strong, but then between this one and this one is weak in between those two. Okay. Ionic bonding is metals and nonmetals. The electrons transfer from the loser to the gainer and make ions. They do not conduct electricity when they're solid because those ions are stuck. But then as a liquid or aqueous, they do conduct. They have high melting points and boiling points, and many are soluble. Okay, so here's some models for it. So here's ionic. Look, the ions, but then they're stuck. All right, metals. All right, you got electrons can move. Woo, woo, look at them moving. And then look, they're shiny, solids, but they have those attractions between them. Covalent, all right, so here's the molecule, and these are molecular, but then the connection between that and that is weak. Here's a molecule, all right, so another molecule, so strong sharing electrons, covalent bonds, and then, but then one molecule and another molecule might be weak. Sugar's covalent, so each molecule makes a connection, but then between molecules, it's weaker. Okay, so to review, we started with molecular and knowing what they mean, so make sure you know your prefixes. 1, 2, all right? Use the prefixes if your molecule starts with a nonmetal. Don't use prefixes if you see a metal, so no prefixes with metal. Full bonds make high boiling points and melting points. Attractions are weaker than bonds, and they make low boiling points and melting points. So we've come to the end so that you can see the objectives again. And we'll keep practicing and learning, and we're going to do some labs too. So that's it for now. Peace out.